If I say 10.0.0.1 should be translated to 11.0.0.1, we are manually specifying. Okay, then dot 2 translated to dot 2. If we specify this individually, this is the static NAT. Alternatively, we have a dynamic NAT in which we will say 10.0.0.1 to 127. This whole range should get translated using 11.0.0.1 to 11.0.0.127 range of IP address. So maybe when a traffic from 10.1 comes, he may use 11.1 or he may use 11.10. We don't know. It's a randomly picked at the time of translation. This is a dynamic NAT. Fine. Okay. So, and both are NAT only. Now we have something called a PAT. What is PAT?
That is a port address translation.
Port address translation. What is happening there? Along with the IP address, the ports also can be translated. So we can say 10.0.0.1. If the port number is 80, translate it to 11.0.0.1. With port number 80, you can do that.
Okay,
If 10.0.0.1 with port number 22, translate it to 11.0.0.5 with port number 22. Okay, so here, but we are not translating the port number, right? But we are referring the port number. So alternatively, what we can do is, I can even say 10.0.0.1 with port number 8080, you translate it to 11.0.0.10 port number 80. So here actually the port number is also getting translated. This is the PAT, port address translation.
So IP also getting translated, port also getting translated.
Both we can do translation, yes. Okay, it's up to you how you configure.
Okay.
But in PAT, we can refer the port numbers also. Maybe just for reference of NATing purpose, or maybe for translating the port number itself. So for some reason, if you are referring the port number also in the translation, then that is called PAT. Clear? So in both the case, so as of now what we discussed, we do a one-to-one translation. Okay. In the dynamic NAT also we can specify for the source and destination range, translation range. So the number of IP address on both should be matching. Now we have something else which is called NAT overloading, or we call it as masqurading. This is when we have a range of IP address getting translated, but the translation range is small. So what we are doing, we have the translation range only 10 IP address, but the source IP address is 127 IP addresses. So how the translation will happen? First 10 communication can be translated to these 10 IP address. What about the 11th communication? We don't have a IP address available in this pool, right?
You will do the subnetting?
No. Subnetting is for allocation, not for the user traffic. Okay, when you want to assign an IP address to a PC, then we can do subnetting. But subnetting and this traffic when it passes through the network, there is no relation. So in masquerading, what happens is for the first communication, I'll just clear the screen. For the first communication, (10.0.0.1), when the traffic comes in, he will pick 11.0.0.1 and he will do the translation. 2, 3, 4 up to 10, he will pick one IP address and translation is done. Now when the 11th traffic comes in, I don't have a IP address to pick. So what I will do is I will use the existing IP address itself. Now I will use maybe 5. But now the problem is already the 5 is translated to 11.5, right? When the reply comes back, I will have a confusion. Reply is coming with the IP address of 11.5. But I have two entry in my, I can translate it to .5 or I can translate to 11 also. But which translation I will do? There is a confusion. To overcome this, they will use the port translation patting mechanism. What is that? When they do the translation, when they send a traffic, they will mark the port number also, right? So here from .5, maybe 22 port number is coming, so I will mark it as 22. But from 11, 22 is if it is coming. If it is 23, there is no problem. Both places I will mark 23. But if both the place 22 is coming, then what I will do, I will translate the port number also. I will use another port number instead of the original port number because there should be a differentiation between this entry and this entry. So both the traffic will
So,
pass to the destination. When the reply comes back, even if the IP addresses are same, the port numbers are different. So he can take a decision, this entry to use or this entry to be used. Got it?
so this is I'm getting confused. So 10.1.1.1, 2, 3, 4, 5.
Tell
So
me what is the
it's also
confusion.
same like a pat only, right? Then.
This is like a pat only, but
Hmm.
actually it is a patting mechanism we are using here. So it
Hmm.
is a patting mechanism only.
But
But the difference is in the patting what we do, we will say 10.0.0.1 with the port number 22. You translate it to 11.0.0.1 port number to 21. We will mention it. We will specify it, the port numbers. What is the source port number? What is the translation port number? But in case of NAT overloading, we are just saying these IP address translate to so and so IP address. We are not talking about the port number. The port numbers are automatically taken care by the device.
oh,
That is the difference.
okay, but we are not specifying here.
Now we are in case of NAT overloading, we are not specifying the port numbers. But again, in NAT overloading also, we have two mechanisms. Statically we can do where we will specify it. Dynamically we will not specify it. Okay. Any question?
Okay. But
Okay.
what is the difference between NAT overloading and PAT? Both both are look like the same. The main difference
See,
is
if I specify a NAT with the source range and the translation range with equal number of IP addresses, then it is
PAT.
okay, normal path. Okay. Again, we can say how to say, this is actually coming under the dynamic NAT, not under PAT, because we are just specifying the source and destination range. We're not talking about the
Mm,
port number. If you specify the
mm,
port number also, then only it is PAT.
mm,
Okay. When you do the patting, and if you specify the port number and if you are using the same IP address, then that is again static PAT, or we can
mm,
say NAT overloading. We can say it's a PAT overloading actually.
mm,
We cannot
mm,
even
mm,
say
mm,
it's a PAT because port number we are not overloading. We are using the
mm,
IP address only. So it's a NAT overloading, static
mm.
NAT overloading.
Okay, but in the
Okay.
case NAT overloading, we have a many IP address, and then when we are translating, we are using a less IP address, and then
But we are specifying we are not specifying the port number. Then it is a
port
NAT
number.
overloading.
But when the traffic comes right, comes back, will it differentiate with the port numbers?
He will translate both. He will translate this port number to
Hmm.
22, and he will translate the IP address also back.
Hmm.
Two translation will happen.
So then we are specifying only IP address, but the system automatically taking care
Internally,
of
it will do that. Yeah,
port
internally it
numbers,
will do that.
including.
If you are statically doing the NAT overloading, then whatever we specified, he will use that.
Hmm.
If it's a dynamic NAT overloading,
Hmm.
then system will take care of that.
Okay. Dynamic
Clear?
photo system will take. Okay. Dynamic photo loading. Okay.
So
Okay.
what
This
is
is
the use
a
case?
yeah.
One use case which we are doing every day in our life is translating your private IP address to public IP address when you have
Hmm.
your home based internet connection or small office
Hmm.
internet connection.
Hmm.
That even bigger organizations uses that. So if I have 5 PC, 5 laptop, mobile, right?
Hmm.
If we have
Hmm.
4 members in family, then they will have 4 mobiles, right?
Hmm.
They will have one or
Hmm.
two laptop, one desktop. So we already
Hmm.
got 6 to 7 devices in a home itself. But how
Hmm.
is the internet connectivity? We are taking a Airtel connection. We are getting only one public IP address here. That means only one device can talk to internet. But all our
Hmm.
mobiles, all our laptops, everything is working, right? How is it happening?
Hmm.
Because your Airtel router is doing
Hmm.
nothing there.
Hmm.
If you check your laptop IP address, it will be a 192.168 dot range.
Hmm. Hmm.
This is a private IP address. This
Hmm.
IP address will not be allowed inside the internet. The Airtel first router, the edge router,
Hmm.
it will drop if any traffic is going with a private IP address.
Private IP.
Yep. So what we are
Okay.
doing on this router, we are doing an adding saying that
Hmm.
192.168.1.x, whatever the IP address is, translated to the IP address on this interface.
Hmm.
So when the traffic goes out, this device will see the traffic, any traffic coming from these devices, he will see
Hmm.
it as it is coming from this interface. This
Hmm.
interface have a public IP address, so no problem.
Hmm. Hmm.
And here I have a 256 or 255 IP address, right?
Hmm. Hmm.
But I'm translating to only one IP address.
Hmm.
So what is that translation? It's a NAT overloading.
One minute to one.
Yes,
Net
NAT
overloading.
overloading. And it is dynamic NAT overloading. We are not saying the port number details. System will, right, look into the port number and he will map it properly to the corresponding device and everything will
Hmm.
happen in automatic.
Hmm. Hmm.
Clear?
Dynamic photo overloading.
Yeah. So this is one use case
Hmm.
of your netting, right? Now coming to another use case. Assume two organizations are merging,
Hmm. Hmm.
maybe
Hmm.
IBM, and they are acquiring another company, maybe called XYZ.
Hmm.
So even if it is a small organization, assume the company is big. Okay.
Hmm.
So
Hmm.
this will take time because in the IBM network, all the configuration will be saying that all the internal devices will have access to their resources. Anything outside, anything other than their specified IP address range, don't allow to the resources. That is how the configuration will be. So once the acquisition happened, once we make this connection, now these
Hmm.
XYZ devices they need to talk to this network, right? They need to access the resources because now they are part of the same company.
Hmm.
But as there are security configurations, they will not allow external IP addresses, different subnets. So what we need to do? We need to convert the whole network to the IBM standard or IBM
Hmm.
IP addressing and
Hmm.
configuration, security, all those
Hmm.
things we need to. It will take right maybe years.
Hmm.
You know how the merging happens in companies, right? Your employees
Hmm.
will get to know, okay, there is a merging happened, but it will take
Hmm.
some time to change the mail address, change the domain
Hmm.
name, right? To get the access to the resources, and a
Hmm.
lot of time it will take. Sometimes depends on the
Hmm.
size, it may take
Hmm.
years also to complete the transition process. So how till that time how the communication will happen? What we can do? We can in short we can do a netting. Whenever a traffic goes, this device will translate it to IBM range of settings, IP address, and all those things.
Okay, there's a
And the,
translation happening from one private IP address to another private IP address.
we can see that depends how the network is, how what is the requirement, how is the existing configuration. Maybe sometimes we may have two netting. For this company
Hmm.
also they will have security configurations, right?
Hmm. Hmm.
So
Hmm.
any traffic coming from there, he will translate and send it inside. When the reply goes, he will translate and send it back. Or maybe he also may do. Depends how many branches,
Hmm.
right? Where
Hmm.
and all devices are there. Anyway, to allow the traffic to inside the organization, there will be a translation of the IP address. This is the
Hmm.
easiest and
Hmm.
shortest way to make these two networks to talk to each other. This is another use case
Hmm.
for NAT.
So basically, one set of IP address to another set of IP address we are
Yes.
translating.
Basically,
And
everywhere we are doing the translation.
hmm.
Only thing is the situation, the requirement changes. That's it.
Hmm. Hmm. Hmm.
The previous case I told for a home user or a small organization, they want to access the public internet. That is the use case. Here we are talking about two different company merging or two different right IP
Hmm.
segmented networks. We are merging them to talk to each other. That is another use case. Clear? So now tell me,
Hmm.
NAT
Hmm.
is a stateless service or stateful service? First tell me what is stateless service, what is stateful service?
I think state full
Why?
because it is remembering the states. Where,
Yes. See, whenever a NAT happens,
hmm.
they creates a NAT table, which I taught before, right? That the translations that is stored
Hmm.
inside the NAT table.
Hmm.
Okay. So inside
Hmm.
this, we will have entries
Hmm.
of all the current translations, whatever the current sessions happening through the
Hmm.
network, they will maintain in the NAT table. So that is called
Hmm.
state information. That is why we
Hmm.
call it as stateful service. NAT is a stateful service.
Hmm.
So when a translation happens, when the traffic goes out and they are making an entry, when the reply traffic comes back and if this table crashes, then the reply traffic will not pass through because there is no entry in the NAT table.
Hmm.
So if the state information is maintained in the NAT table, then only the communication will happen completely.
Hmm.
Okay. So this is a
Hmm.
NAT is a stateful service. Now there
Hmm.
is a small glitch here. What is that? We discussed yesterday. We can have a active or active standby edge.
Active standby. Okay.
Yesterday we discussed, right? Active and active
Yeah.
standby SR routers, right?
Hmm.
So this NAT is a service. So where is actually it is happening? Services are running
Hmm.
on SR routers.
Hmm.
So if your service is active, can you run NAT?
Active. We can run, right?
No. NSX-T is not supporting any stateful service if you are running active. Because
Wow.
in active what happens? One traffic will pass through this, another traffic will pass through this. Maybe when the reply comes, it may go in another way.
Hmm.
Both are active, no? So
Hmm.
the translation information is here. I don't know about the translation information.
Hmm.
So the traffic will fail. Okay. So stateful services are not supported if you are using active service. So to overcome
Hmm.
this problem,
Hmm.
they came up with another type of NAT. Okay. It is called see, I believe it is reflexive. Yeah. It is another type of NAT which is called reflexive NAT
Let's see.
or stateless NAT. If the NATing is stateful, then only it is a problem, right? If I
Hmm.
say I don't need a state information for my NATing, then the problem solved.
Hmm.
So how it happens is this is your router and you are doing NATing between these two networks. Okay. Now here, when you define a reflexive NAT, what happens is, as we discussed before, we will do the ranges. We will specify the ranges 10.0.0.1 to 127. Then 11.0.0.1 to 127. Okay, the conditions. First, this number of IP address should match with this number of IP address. If we have 128 IP address, here also 128 IP address, mandatory,
Hmm.
one condition. Okay. Second condition, or the way how it works is, the first IP address in this pool will use the first IP address in this pool. So 10.1 will always will get translated to 11.1.
Hmm.
Second to second, third to third, like that. All one-to-one mapping will be there. Okay. So now assume that I don't have a net table.
Hmm.
Okay. From 10.10, I'm sending something to external network. So what translation will happen on this device?
10 to
10.10 will be translated to 11.10 always, the 10th IP address, right?
hmm.
So there is no confusion. I don't need a table to refer this. We have two
Hmm.
range specified. I always will do the similar number of IP address in the pool.
Hmm.
Right, if the
Hmm.
10th IP address, then from the other pool, I'll take the 10th IP address. No confusion.
Then. Hmm.
So if I have two active device, then what will happen? When I'm sending
Hmm.
traffic, I'm sending through this. So
Hmm.
this is getting translated and traffic going to other side.
Hmm.
Now assume the reply is coming through this path.
Hmm.
Is there any problem?
Then,
He will see 11.10. So if he see 11.10, he know 11.10 should be translated to 10.10 and reply will come back. No problem, no confusion.
okay.
But in the
It's a
normal
loop.
NAT,
Hmm.
there is no
Hmm.
condition like which IP address to be used. Maybe 10.1
Hmm.
may get translated to 11.100, maybe to
Hmm.
11.5. There is no condition. Any free
Hmm.
available IP address from the pool he will pick. Okay,
Hmm.
so this is the
Hmm.
reflexive NAT.
Hmm.
Any question?
So it is 10 to 1 to 1 mapping only, right? Then again,
Yes. Yeah, that
in
is a
secondary,
condition.
hmm,
Then only you can do
same IP,
reflexive NAT.
same IP address mapping, same
Same, same IP address in the
hmm,
sense.
1010 or 1110, like that. The
No,
10
no, it
9
need
to
not to
9.
be number match. It is not number matching. Okay, right side
Hmm.
you can even use 11
Hmm.
dot 129 to 255. No problem. See here 128 IP address is there. Here also
Hmm.
128 IP address. That's it. So
Then
10th
in that
IP
case,
address
it's
in
a
this
dynamic
pool, 10th
group
IP
to
address in
group
this
to group.
pool will use 10th
Hmm.
IP address in this pool. That is the only thing.
But in the case, that is same like a group to group translation we are having, right? Same like, but we have to match the IP address, the
Number
number
of IP
match.
address we need to match. Yes.
Number of IP address we can match, but then in that case, it's a kind of dynamic net, right? This one.
It's a dynamic NAT only.
Okay. But you were explaining with the two routers, right? The left hand side, 10 to 10. I was not getting. I little uh,
Still
confused.
not clear?
Yeah, the left hand side, the diagram which you made, right? Two router.
Huh.
If
Two
possible, you can
router I
explain.
am explaining with an NSX-T. This is the
Hmm.
SR of your
Hmm.
right T1 or
Hmm.
T0. That is what we were
Hmm.
discussing, right? If it is active, active, we cannot work. This NAT will not
Hmm.
work. Only for active standby it will work. But this reflexive NAT will work on active, active also. So two router I showed you to show that these two are active, active routers. Still, reflexive NAT will work, and this is how it is working.
Both are active, active. Then reflexive NAT will work.
Reflexive NAT will work, but the normal NAT will not work because
No.
they need a state information.
Okay. So in a active active combination, reflexive NAT will work. So then normal NAT why will not work? That is also
Normal
we can
NAT, that's
configure. Hmm.
see here we have a NAT
Hmm.
table.
Hmm.
Okay, when 10.10 goes, this
Hmm.
router is deciding, okay, I will use 11.10.
Hmm.
He may use 11.100 also, no condition, right? He can pick any IP
Hmm.
address. Now
Hmm.
assume that the
Hmm.
reply is coming through this.
Hmm.
This router don't know, right? What is the translation used in the other router?
Hmm. 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 Hmm.
He will not have entry in his NATing table, so he cannot do the
Hmm.
translation. Then he will drop it
Hmm. Hmm.
for a normal NAT because normal NAT is working based on the state information in the NAT table. But in reflexive NAT, he is not referring any state table. He is just looking into the configuration and he know
Hmm.
if this is a 10th IP address, I need to use the 10th
Hmm.
IP address. That is it's unconditional, right? That is always that is the rule.
Hmm.
There is no other
Hmm.
choice.
Hmm. Hmm. Okay.
Fine.
Dynamic NAT. Question dynamic NAT. Hmm.
And one more
But
thing, T0 can configure in active active or active standby modes. But T1 is always active standby. There is no active active option.
okay. T0 will be configured in active as well as active standby.
Your choice.
Hmm. But T1 will prefer only we have to make it active standby only.
Yes.
T1. Why is it so
That is how NSX-T is designed.
designed? Okay.
Yeah.
Hmm. Hmm. Okay, sir. Okay, sir.
Okay. Okay. Now we discussed about NAT.
Mm,
Now, what we are translating, based on that, we can say source NAT and we
mm,
can say destination NAT.
mm,
Okay. So if a PC
mm,
10.0.0.1 is sending a traffic to
mm,
20.0.0.1. So what will be the source
mm,
IP address? Source IP address will be 10.0.0.1. What will be the destination IP address? It is 20.0.0.1.
mm,
And here is the router who is doing the translation. And if he is
mm,
translating the source
mm,
IP address, and when he
mm,
send it, he is saying 11.0.0.1 is the source, and traffic destined to 20.0.0.1. So here what IP address is changing? The source IP address is getting translated. Destination remains same, right? On this router. So if the source IP address is getting changed, then that is called source NAT.
Okay.
If the destination IP address is getting changed,
Mm,
then that is called destination NAT.
mm.
Clear?
So if the source IP got changed, then it's a source NAT.
If source IP is changing, then that is a source NAT. If the destination IP address is changing, then that is a destination NAT. Again, I will tell you two scenario. Okay, use cases. So I told you the internet scenario, home based or small organization based. This is source NATing. What we are doing? 192.168.1.x IP address. We are translating to this interface IP address. So source IP is getting changed, but the destination, I'm trying to ping to Google or I'm trying to reach Google. So that destination will remain same from here till the end. Only the source IP address will change. Clear?
Not much.
So at home,
Mm,
our home-based
mm,
internet or small office, what we are doing is a source NAT. Now, what is the use case of destination NAT? For example, at your home, you have your laptop,
mm,
okay, and you went to some friend's place. Now, from your friend's home, you want to access your laptop. You want to take RDP to your laptop. Is it possible? What do you think? Is it possible? Your laptop IP address is private IP address. From internet or from any part of the internet, you cannot access any private IP address. Or you can say your internet is not aware about any of your private IP address. So if you are trying to access your laptop, which is configured with a 192 IP address, you cannot access it from here. So what is the alternate option? On this router, you can configure a destination NAT. What we will do, from this device, I will do a RDP to this IP address. But on this router, I will configure if any source, okay, X source. If the destination is 202.0.0.1, then translate it to 192.168.1.10. Now what will happen? You can do a RDP from your friend's place to this public IP address of your internet connection, and this router will translate it to the 10 dot sorry 192.168.1.10 IP address, that is this IP address. So traffic will come here. So you will be able to access your private resources from public network if you configure your destination NAT. So this is one use case. So in source NAT, the source IP address was getting changed, but in case of destination NAT, the destination IP address is getting changed. Any question here?
Just I am thinking private to public only. Okay. I think this is the scenario you explained previous also, but this is okay. Just private to public, right? There is the one. I think it is a
This
static net.
is
Uh,
this is private to public.
mm,
This is a source NAT.
mm,
Traffic is originating from here and
mm,
going to public network.
mm, mm, mm,
But this is traffic is
mm,
originating in the public
mm, 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 mm,
and coming to your private network.
mm, 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 mm,
So your public network is public IP address is getting translated to private, but here
mm,
private is getting translated to public.
mm,
Reverse.
mm, mm,
Clear?
okay, here we are having a private to public. There we have
Again,
public to.
again, I'm telling you, private to public or public to private is just a sample. Okay,
Mm,
it is all
mm,
about the direction of the traffic.
mm, 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 mm,
Okay, so if you are translating the source IP address when
mm,
the traffic passes through your device, then it is a source NAT. If you are
mm,
translating the destination IP address when the traffic
mm.
passes through your device, then it is a destination NAT. That's it. Private, public, public, public.
Oh,
That's all.
okay,
Just
okay.
an example. Okay,
Mm,
clear?
mm.
These all are
Basically,
CCNA concept. Okay, network basics. I'm not talking anything new. You are
yeah, yeah,
supposed to know these all things. Okay. Okay. Anyway,
yes,
this is like a revision for you, right? And if you are
okay.
missing something, then it is like a gap filling. Good for you.
Mm, mm,
Only about NAT, I can talk another right a full session. I can take 3 hours at least. More than 3 hours, I can talk. Okay, that much is there. If I go in this speed, but if I go with
yeah.
the packet structure, how the translation happens with the examples, everything, then
Mm.
for 5 hours it will go.
Oh, okay.
Okay, that much information is there on NAT.
Mm, mm,
Okay. Anyway, so overall, you got the idea. Any
yeah, I got
confusion?
that.
Anything you are not getting?
No, 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 no. Source NAT destination only. Just source IP getting changed. That is not uh, source NAT and destination IP getting
Yes.
changed. Then that is a destination NAT.
Yes.
Okay.
Watch the video again and again. Okay, by
Mm, mm, mm,
seeing right how you respond, I understand that NAT is not so clear for you. So you
mm,
repeat it, watch 2-3 times, then only
mm.
right concepts will be clear.
Yeah, yeah, correct.
Okay, all right.
Okay.
So now we'll come to NSX-T. Till now we were
Mm,
talking about NAT, not about
mm,
NSX-T.
mm, mm,
Okay, all right. So anyway, these all information is required for our NSX-T discussion. So we will see how the NAT is applied on your NSX.
mm,
So we
mm,
already discussed about a T0 and T1
mm,
router.
mm,
We
mm,
can do
mm,
NATing
mm,
on both the routers.
mm,
Okay, NATing is supported on your T0 and T1. Okay,
mm.
all right. Now, as we discussed, source NAT, destination NAT, reflexive NAT, all are supported in your NSX. Okay. All right.
Are supported in NSX-T.
Right. So these all are supported in NSX-T. Now this can be static or dynamic, right? Whichever we can configure dynamic, that is also supported here. Okay. Now, how do you do? For example, if we have a T0 or T1, both are same way how we configure it. I'm taking T0 as an example. Okay. Now we have a web segment here, and I have web VMs here. Now, on this router, we will configure NAT. To configure NAT, the expectation is we already have our T0 deployed. The segment is created. Segment is connected to the router. VMs are attached to your segment, and there is a uplink connected to this. If it is a T1, uplink connected to T0. If it is a T0, then uplink connected to physical router, whatever it is. So the network is already up and configured. That is what the expectation for NAT. Now, on your NSX-T tab or your NSX-T UI, on the networking tab, you have on the left side, you need to uh, select your router. Okay, so you have two choice, T0 router and T1 router. You need to choose T1 or T0, whichever you want. You can select that. So when you select that router, okay, so sorry, that from the T0 T1 you need to deploy the router. Okay, and you make all these connections, everything. Then below this you have a NAT option is there. So click on this NAT. When you click on this NAT, you will get a pop-up asking which router you want to use, T0 or T1. You can select which router you want to configure NATing. So once you select that router, then you will get a option below add NAT rule. So here you can specify all the rules. So what we are doing, we are selecting the router, then we are giving the statements. What are the translation we need? That's it. Okay. Now, where is this NAT will be running? On your normal transport node or edge transport node?
NAT will be running on T0 normal transport node.
NAT is a service, right?
Mm.
Service will be running on
Edge.
edge, right? NAT is a service. Service will be running on SR component of your router, and SR component is running on your edge node. So, in simple words, your services are running on your edge node. Clear? Okay. So when you write the NAT rule, you can say you need a destination NAT or source NAT or reflexive NAT. All those things we can specify. Okay, it's a GUI configuration. It is very simple, nothing complex in this. Okay, so most probably I will give you a lab. I will show you a demo. Okay, from starting from beginning to till today, whatever we covered, so that you will get clear. If you have any confusion, because lab manual when you read and do it, you may get some confusion, right? So, but I can explain it once so that all confusions will be cleared.
Okay.
Any other question?
No, no, sir. No, sir.
Okay. So NAT is over.